Alright, if you recall last time we did make a basic movement system for the start of our maze game here, and today we're just gonna make, a hazard. Drew the spike right here. This is what it's gonna be. Yours can be whatever you want. It could be lava. It could be, just draw up something nice that you could use for a sprite for the placeholder of this spike. Now the object itself has started with nothing. We're gonna probably keep this clear for a while here, but we'll focus right now on the player's movement. That's where we left off. So you can see we have them all separated here, left, up, right, down. This is not ideal because if you make a change in, say, the up code, it's not going to transfer over to these, and we want that to happen. So instead of making an individual script for each of these, we're going to make a function, which is a script, and let's name it move. Yeah, that works. Let's define some arguments here. So arguments are built into Gamemaker, and it's what you pass the script. So it starts with arg0, I believe, or argument 0. Yep. And then it goes all the way to argument 9. So you get 10 arguments. But we need to know who the player is. So we'll do arg0 is object that is moving. We need to know who is moving in this situation. And we need to know also how fast they're moving in both directions. So let's do horizontal speed. arg2 is vertical speed. And you'll see in a second why we separate it like that. It essentially just makes it easier for us to write this code here. So we're going to borrow this here. There was a reason we wrote this. So, okay. So now instead of just simply saying, okay, if collision rectangle bbox left, we're going to do arg0.bbox, or argument 0. Dot bbox left. Bam. For the top, same thing. Arguments 0. Dot bbox top. And we will, in this case, we're going to make the rectangle cover the entirety of the sprite. Before, we were just doing it from where they were moving to the point that they were going to move to. So, you could see we had bbox top, and we were doing bbox top minus 2. We're going to actually, since we want a general case for movement, and we want to generalize it for all movements, we're going to make this cover the bottom now. And again, argument 0. So this says now this is taking whatever object we give it, and it's checking this movement. We're going to keep wall here too, because I do think this is going to be a movement for standardized objects, and every object is going to need to collide with the wall. And if we need something that's a special case, we could always program that in later, and keep the rest of that the same there. So if collision rectangle, bam, we got all that there. Okay. So this is our movement here. So we're going to do arg0 dot y, or argument 0, is and we're going to do a positive equal here. Instead of doing negative equal, we'll just do a positive equal to argument 2, and then this way we can tell it, we can give it a negative number if it's going to be moving negative. If not, we'll give it a positive number. Dot x. Same thing for the the horizontal movement. Okay. And here we are going to need to pass in for the left and right movement. We're going to give it the horizontal amount that we're moving by, and this will again work for both sides. And for the vertical, we're going to do the same, but with argument 2. And it looks a little confusing, but again, when you get used to writing this kind of stuff, it'll just be second nature. And we can add some comments in to help with that, but it'll work fine. We're gonna test this now. So let's also do a return here. That would be interesting. This way we can also get data back from move if we want to know if the move was successful. Return false if we don't move, and return true if we do. And make sure your return is after all of your code that you'd want to execute. Because if it's up here before this, you're going to return out of the code before you execute the move. So there we go. And, rather than having it separated like this, we're going to delete these events. There's probably an easier way to do this. No big deal. And we're going to put it into step. It's a general event that happens every step through the game. Wow, we've got a lot of things here. Okay. And we're going to do some keyboard testing. So if keyboard is check pressed, VK left, and you know what, we're going to come up with a custom variable here. Now we're going to take each key press, and if it has an effect on the movement, we're going to set these variables appropriately. Let's give it some brackets. We'll be proper here. We're going to make it move a little faster than we did before as well. So next move equals -3. And in this case, we can do an else if. This will be VK right. And VK is just Gamemaker's standard constant to designate the keys. So VK left on the keyboard and right for the arrows. And we'll do another one if VK up. I gave it the wrong value there. That's quite alright. Let's go back and change that. And then after all this is going to happen here, this will tell us what direction we're going to move. So now we have to tell it to move. We're going to call our script just by the name there. And you know what? We didn't do this before, but let's call it script move or function move. That would be fun. This way we know that it is a function. It's not an object, not a sprite. These are called prefixes, the func, and you want to put them in just so you know what you're talking about when you designate things. So func move, give it the ID of the object. That's the first one if you remember, so we know who's moving. Give it the movement. I believe the first one was actually, let's see, so argument 1 is indeed horizontal. So yeah, well, let's try that out. I hope it works. There's a lot of things we could have done wrong, but it looked good. Alright, there is an error. Unknown variable xmove. So, I'll show you where that comes from. In the case where no key is being pressed, xmove is actually left undefined, so is ymove. And that is something I didn't think about. Let's just do that for now. And yeah, you could do this without the variables, but I like to do it for that way for now, just to see. Oh, we're running into the same problem. At least the movement is working, and the collision's working too. That's nice. But we're gonna change this right here, check press. So Keyboard check press, keyboard check direct, keyboard check. That sounds better. It's actually been a while since I've written GML, so I'm going through this just the same as you guys, almost with a fresh perspective, except I do remember how I did things. But it's been a little while. Oh, that's nice. He's moving pretty well there. Gets stuck on the walls, but that's if you're trying to go that direction, so we can make that smoother in the future, but for now, oof, we are stuck there. Ha! We're gonna have to work on that one. He does get stuck. You know what? Let's worry about that at the next video. For now, we're going to make a hazard. Let's put some of those spikes in the room. So you can see what we did though is we simplified the movement script, we made a movement script. This simplifies the event. We don't have to have 4 different events and look through each code to see if we modified anything. And this is going to turn out to be very beneficial for when we check other collisions, like collisions against these spikes here. We do only have one direction for the spikes, but we'll test that. So let's make another script here. Check hazard. Why not? Because maybe there will be multiple hazards, and we'll handle all that here. We can also do it in the move, but I like to keep it clean and have everything that is pertaining to just one simple function in a function and not get too overcomplicated. This way you can generalize this movement to other objects, maybe objects that don't have hazards. So it's going to be similar to this, but we don't need movement here because we already are going to move before we check this. So essentially just getting rid of the movement. And we're going to check for object spike. In this case, when we do collide, we want to know there is a hazard. And let's do a check here. So function move, after we move, check to see if we have hit a hazard. No. And we just need to give it that. And I did just remember, let's get rid of this. And also, let's keep our comments good here. Alright, so if there's a hazard, we don't actually just want to call that, we want to call an if statement. And that is implied to be if function check hazard equals true. I just hope you guys know that. We don't need to put equals true. We can just call that. If it's true, x equals x start. How about that? We'll just teleport him to the start for now. In the future, we can have it take away a life. I just want to make sure this works. Else don't do anything if there's no hazard. Let's actually get rid of that. Boom. Alright. Nice. So, if you hit a hazard now, you do die. And let's try to think what we should do next. How about this? How about we have the player facing the direction of where we're moving? That would be interesting. So we're going to do it in the movement script. Since we have it, we might as well use it. We're going to do argument 0 dot image angle, and that is the angle of the sprite. And you'll notice our sprite is facing upwards. That is not 0 degrees in this game. That is actually a 90-degree start. So we're going to want to subtract 90 degrees from this value because we want to write the sprite. We want to start the sprite at 90 or at 0 degrees, not 90. So image angle equals point direction. This gives you an angle when you give it two sets of starting points. It gives you an angle between those points. We're going to start at argument 0.x and y, and then we're going to give it .x plus argument 1, argument 0.y plus argument 2. So now we're setting the image angle equal to that angle right there. And we want to subtract 90 from it because I believe that will write this issue here. We could also just rotate the sprite and bring it into the right orientation, but we might as well do it in the code. Let's see if this works. I'm not sure it will. You'll notice I'm running the game a lot. I like to debug and test quite often. It seems to be the best way to ensure that you're doing the right thing. So there was an issue there. It looks like when we're not moving, he is going left by default. So yeah, so instead of, let's do this. How about this? We got to check to make sure that argument 0 and or argument 1 and argument 2 are not both 0. We're going to return false if this is the case. This is basically saying, okay, if I'm going to put them in brackets, it's just pretty good practice. So if they're both not going to be moving, then we're just going to get out of the script, and we're not going to change the direction that he's facing. We're not going to do any of that. And now you'll see it works a lot better. Oh, look at that. He's facing the direction he's moving, and he collides well. Oh, that's beautiful. Oh, he gets stuck still. We're going to have to work on that. But anyway, we'll take a look at that next video. So this is it for now. We have collisions, we have movement, we have angles, and just some basic, taking advantage of Gamemaker's basic built-in functions. So when we get back tomorrow, or the next video, hopefully tomorrow, we will put in some sounds. We'll put in a life counter, so he has a set amount of lives, and we can subtract that when he hits a hazard. And we'll probably make some more functions, perhaps a cleaner movement script so that we don't get stuck on the walls. But that's it for today, guys, so hope you enjoyed.